Hello, my dear friends and students. Welcome to today's session where we have to see the DC motor. In last session, we have seen the DC generator, and in this session, we are going to see the construction and operation of DC motors. So, introduction related to the DC motors. As we already discussed this one, the DC machines are of two types, namely DC generator and DC motors. DC generators converts mechanical energy into electrical energy, whereas DC motor converts the electrical energy into mechanical energy. That means for DC motor, input is electrical energy, and the output side we are getting mechanical energy in the form of rotation of shaft. In order to understand the operating principle of a DC motor, it is necessary to understand how does a current carrying conductor experience a force when it kept in a magnetic field. So the basic working principle of DC motor states that or says that when a current carrying conductor is placed in a magnetic field, it feels a force and it starts rotating. So we have to understand the basic of this. Okay, so for example, we take a simple straight conductor, which is current carrying conductor. That means current is passing through the conductor. So according to thumb rule, if you hold in your right hand the current carrying conductor, then thumb indicates the direction of current, then the curled finger indicates the direction of magnetic field produced by that current. So if a straight conductor is placed in a magnetic field produced by a permanent magnet, then current flowing through the conductor in anti-clockwise direction. Due to the presence of two magnetic fields simultaneously, an interaction between them will take place as shown in the figure. So you can observe this figure, inside this main magnetic field. That means there are two permanent magnets, N pole, S pole. Magnetic flux lines outside the magnet is shown from N to S, and a current carrying conductor is placed in the magnetic field. So this current carrying conductor, this is centrally located. Okay, so when current is passing through the conductor, it will create its own magnetic field. And according to, you can apply over here the right hand thumb rule. According to that thumb rule, if current is going inside the plane, current is going inside the plane, then you can say that curled finger indicates the direction. So it is a clockwise direction of magnetic fields produced by that current. So you can see that in half of the portion, the direction of main magnetic flux lines and the direction of magnetic field produced by that conductor or current carrying conductor are in opposite direction. So they will cancel each other, and in a right side you can say this direction of main magnetic flux lines and the direction of magnetic field produced by that conductor are in same direction. So here addition takes place, and because of this it feels a force, because in a half of the portion the net magnetic flux is zero, and here addition is takes place. So this will create a force, and that force is defined, or that direction is given by this arrow. So this resultant magnetic field, or this current carrying conductor, feels a force and it starts rotating. So as shown in figure 1, the flux lines produced by the magnet and the conductor are in opposite direction to each other at left side, and hence cancel each other. Therefore the number of flux lines at the left side will reduce. At the right side the individual fields are in the same direction, hence it will add or strengthen each other. Therefore number of flux lines at the right side will increase. So the magnitude of that force, because of this current carrying conductor placed in a magnetic field, it feels a force, and that force is given by, or the magnitude of that force is given by, F is equal to BIL, where B is nothing but flux density produced by the magnet, I is nothing but current flowing through the conductor, and L is nothing but length of the conductor. Simple working principle of DC motor is that for complete the operation we require three things. First one, individual magnetic fields. Second one, interaction of these two magnetic fields. And third one, force is exerted. So to generate these individual magnetic fields, we know the construction of the DC motor, that again we are going to discuss in the next portion or next PPT. So magnetic field is produced by field winding, and a current carrying conductor is placed on the armature. So interaction of these two magnetic fields takes place and force is exerted on the conductor. Resultant force is exerted on the armature, and armature start rotating as per the direction of force exerted on that conductor. So the direction of that force is given by Fleming's left hand rule. What it states? It states that if the first three fingers of the left hand are held mutually at right angle to each other, and if index finger indicates the direction of magnetic field, and if middle finger indicates the direction of current flowing through the conductor, then thumb indicates the direction of force exerted on that conductor. This can be shown in next figure. So you can understand or you can apply your left Fleming's left hand rule over here. Magnetic flux lines indicated by the first finger, direction of current flowing through the conductor is indicated by the second finger, then thumb indicates the force exerted on that conductor and it starts rotating in clockwise direction. So on this basic working principle, DC motor works. So windings used in DC motor, we for to achieve this motoring operation we required two windings. First winding is field winding, where we required to give the supply to the field winding. So that field winding is mounted on a pole, and that pole will act as an electromagnet and magnetic flux lines can be produced. Second one is armature winding, where we have to give another supply to the armature winding. So armature winding is connected to all the conductors placed on the armature, and if current starts flowing through that conductor takes place, then it will create its own magnetic field. Then the interaction of these two magnetic fields takes place and force is exerted. So the working principle of DC motor, as we have discussed earlier, when current carrying conductor is placed in a magnetic field, it experiences a force. In case of DC motor, the magnetic field developed by the field current, that is current flowing in field winding and armature winding, plays the role of current carrying conductor. So armature winding experiences a force and starts rotating. This is all about the working principle of DC motor. Further the construction and operation we will see in next session. Thank you all.